so it doesn't really matter what acid source we use most of the time. As we travel along our journey in organic chemistry, we are going to learn a lot of acid-catalyzed reactions. I've listed several here, though this list is not meant to be exhaustive. I'm not going to go through each of those reactions. I've got separate videos on all those reactions down below. What I want to talk about today is how we set up those reactions, what reagents are needed for those reactions. When you went through and learned alkene hydration reactions, it may have looked something like this with an alkene and water and H2SO4. When you learned alcohol dehydration, you may have seen H3PO4, phosphoric acid, as the reagent. And when you did Fischer esterification, it may have been just generic H+. How do we know what acid we're supposed to use for a given reaction? It turns out it doesn't really matter which acid we use, most of the time. I'll explain in a second. When you look back at your alkene addition reaction, if you saw this reaction in these three different versions, would you know that they're really all the same reaction? Or would you get confused by the different kinds of acids used in each example and kind of not know what to do anymore? Would you think that maybe it's something different now, that it's this whatever TsOH is, and not the same as H3O plus or H2SO4 or H plus or any other generic acid? This is a bit of a conundrum in organic chemistry. For the most part, it doesn't really matter which strong acid you use for an acid-catalyzed reaction. I mean, it kind of says it in the name. It's just acid-catalyzed. It's only catalytic in acid. The acid isn't actually part of the new product. It's just a catalyst in the mechanism. So it doesn't really matter what acid source we use most of the time. So I want to go through a list of a few generic acids that can be interchangeable in this course. First, we have H2SO4. H2SO4 is by far probably the most generic acid. It's kind of the one I reach for all the time when I just need a generic strong acid. You probably see H2SO4 a lot. But you might also see H3PO4, phosphoric acid. These two acids are essentially interchangeable in organic chemistry. Anything that uses H2SO4 can also use H3PO4, and there's really not much of a difference. You may also see generic H3O plus or even generic H plus sometimes. These are okay. They're not really my favorite, and I'll tell you why. They don't really exist. What I mean by that is you don't go to chemistry store and ask for their finest bottle of H+. That doesn't exist. You can't do that. H3O plus is what happens when you add an acid to water. When you add sulfuric acid to water to make 6 molar sulfuric acid, what you're making is H3O plus. H3O plus is what happens when you add acid to water. And H plus is even more abstract than that. Naked H plus just doesn't exist in solution. You just don't have blank H plus floating around. It's always H3O plus, and H3O plus always have some kind of counter anion, and the counter anion comes from whatever acid you used. So the counter anion to H3O plus could be HSO4 minus or H2PO4 minus, whatever acid you use to make H3O plus. So there's nothing wrong per se with H3O plus and H plus. It's just not actually what you add. You add sulfuric acid. You add phosphoric acid. There's one final acid I want to add to this list, and that's PTSA, also sometimes called TsOH, which is also confusing that it's got two completely different abbreviations. And what is that? You may not have seen it. You may actually never see it in your course, but if you do, I want you to be aware of it. This molecule is p-Toluenesulfonic acid. P-Toluenesulfonic acid is a strong acid in organic chemistry. In fact, if you look at the right side of that molecule, it kind of looks like H2SO4. Just with this benzene ring thing over on the left side. This is p-Toluenesulfonic acid. That's a long word, so sometimes we go by its abbreviation, PTSA. And this part that I have highlighted in blue is called a Tosyl group, and Tosyl groups are abbreviated TS, just like a methyl group is abbreviated ME, or a phenyl ring is abbreviated PH. The Tosyl group is abbreviated TS, so we can also call it TsOH, Tosic acid, TsOH. All of these are kind of interchangeable for this one molecule. This is a really nice, strong acid. I like it. I use it a lot when I do organic chemistry. I like it because it's organic soluble. We do organic chemistry in organic solvents. We don't do a lot of organic chemistry in water as a solvent. So if we use an aqueous acid, they're not going to be soluble in our organic solvents. But Tosic acid is an organic soluble acid. It's an acid that is soluble in organic solvents, and it's a strong acid in much the same way that H3PO4 and H2SO4 are strong acids. So these are all interchangeable. So when you see your reactions, when you're making your reaction sheets, when you're writing your 3-phrase sentences, when you're organizing nucleophiles and electrophiles, those are all really good study tips, and I have videos on those study tips linked down below. when you make those, don't get hung up in whether you see H2SO4 or H3PO4 or H+. Know that this list of acids is interchangeable. They are just acid catalysts. It doesn't really matter which one you add. Before we close, let me show you a couple of acids that I would prefer you not use as a generic acid catalyst. One would be something like HCl or HBr. Why? Because the counteranion, Cl- and Br- are themselves nucleophiles. If you think back to the alkene addition reaction where you have an alkene, acid, and water, if you use HCl, well, an alkene and HCl is its own reaction. That's the hydrochlorination reaction where you add HCl across an alkene. So if you use something with Cl- as a counteranion in water, you have competing nucleophiles, and you may not be getting the reaction that you think you're getting. Another acid that I wouldn't put on this list is HNO3, nitric acid. Nitric acid is an oxidizing acid. Nitric acid will oxidize organic molecules, and that may not be what you want to have happen in your reaction. You don't really want an oxidizing acid in your reaction. So I wouldn't use nitric acid interchangeably in this list either. True OChemNinjas know that this list is more or less interchangeable.
Thanks for joining us today, Ninjas. Be sure to watch these other videos to level up your ninja training even more. As always, don't forget to like and subscribe.